about. And as I was waiting for my lunch, I was speaking to someone, and they said, you know, there are a lot of teachers here, and teachers really are looking for things that they can take back to their classrooms tomorrow. And nothing that we heard this morning really helps them with their jobs. And I think what the session that we're about to have is the session where things that you can take back to your classroom are going to be presented. And I want to say just two things about that. One is that someone else said to me, "Oh yes, this is the speed dating part of the program, right? That this is where we all get introduced." But as we get introduced in the speed dating part of the program, there will be another part of the program after the formal conference ends at 3 o'clock, where all of the presenters will have tables outside the conference hall. And you'll be able to learn more about the specific tools and resources that they've presented here, and learn more about how you might be able to put those to work in your classrooms. The other thing is this, as you know, we're at Stanford today, and one of the traditions in academic life is that no one ever speaks for less than 20 minutes. It's just something that you're taught in graduate school. And today, all of the presenters have been asked to limit their presentations to 5 minutes. And this is revolutionary from the point of view of Stanford University, but they've all agreed, and so they're going to give you very quick, and this is why we call it speed dating, they're going to give you very quick introductions to the work that they've been doing, and you'll have opportunities for much more interaction with them after the program. With that, I'm going to introduce Mohammed, who will introduce our
This next part is one of the most exciting parts that I'm looking forward to learn about lots of great technology very quickly. And if you have your mobile devices, I'm sure you will do your own research right away and talk to people individually. The best person to moderate this panel is none other than Mike Cassidy. Mike has been a journalist with the Mercury News for over 25 years, and he's been a columnist who writes about Silicon Valley for the business section. So he's covered, and he's dabbled in education technology as well over the past few years where we've worked together, although he never quotes me. He says, I'm not quotable, but I can provide him background. So I got a chance to introduce him today, so interview him, and I'm not using any of those notes either. You know, he's got two high school students in Silicon Valley schools, so he knows a lot about education. He's got a great passion for this. Mike grew up in the suburbs of Chicago and a product of Illinois public schools, and went to the University of Illinois. I'd like to introduce Mike Cassidy.
All the cool guys are only on background. If you're actually quoted in the newspaper, yeah. But anyway, if you can hear me, just keep clapping. Thank you, thanks. I prepared just a stunningly inspirational speech. Nothing much, 30 or 40 minutes. And then I was told, look, buddy, your only job is to make sure no one, under any circumstances, spends more than 5 minutes presenting their world-changing idea. So when you're asked to do only one thing, I figure you better do it right. So I'm going to be really tough. Don't let this calm exterior fool you. I got 3 brothers, and I know how to handle myself. So it's 5 minutes, and that's it. Really. Just think of it as, all the cool technology showcases, they have these time limits. So, just think of this as an elevator pitch for a really tall building. So that I don't break my own rule, we'll get started quickly with Agile Mind, and I believe it's Linda Chaput. Chaput? Okay, well that was very quick, thank you. Linda? Oh, ready.
Hi, I'm your first speed date. I'm Linda Chaput. I'm founder and chief executive of Agile Mind. The better to get through this speed date, I put my presentation on slides, although they don't seem to be advancing. Agile Mind is an education company that's focused on supporting instructional innovation at scale. And these are the ways we do it. I apologize to Edward Tufte and to you for the number of words, but I wanted you to understand what we're trying to achieve. Our focus is mathematics and science. Our focus is the journey into, through, and out of adolescence. Since 2004, we've served 20,000 educators and more than 2 million students. 80% are in underserved communities. We're also deeply informed by the 20% that are in high-performing systems. They help us make sure that our work is worthy of the students we serve. In founding the company, I took inspiration, I'll use an example from Stanford, where I was privileged to know innovators who took remarkable technologies into the public sector, transforming contraception, biotechnology, drug discovery, and computing technology. So we worked to form public-private collaborations that could bring the best work of the best educators to communities. Whoops, my apologies. I'm not sure whether you all are familiar with the work of Uri Treisman, who is the head of the Charles A. Dana Center. His efforts at Berkeley to study the factors bearing on high achievement of students, of minority students, have led to some very pioneering work in education. The Dana Center has built on that, and they were the founding collaboration for Agile Mind, although since that time, our work has grown to involve other public-private collaborations. We use a low-cost fee structure that allows us to sustain our work. Fees from the districts we serve fund 80%, now almost 85%, of what we do, and additional R&D has been supported by federal and private foundations. Our vision is creating a comprehensive suite of programs that support teachers and students from middle school through advanced placement, through early college. And the early data, which I hope to show you, show evidence of transforming student engagement, achievement, and persistence in mathematics. In addition, bearing on the issue of today, as we look at algebra, our approach has been to focus on algebra readiness, on what happens in algebra, and what happens after algebra. And in doing this, we have several programs. Phil Darrow talked with you meaningfully about the Common Core state standards, and with the help of several foundations, we've built a version 0 and a version 1 program to help teachers and students make that migration to the Common Core. In addition, you'll notice here, for students who are behind, we've created an extended experience, Algebra 1, that's designed to support students who are 1 to 3 years behind in getting back to grade level, joining their peers, and being on track to graduate from high school, college ready. I'm down to a minute, so what I'm going to move is show you some data. Mohammed spoke about a girl who was the first in her family to go to college. In the Rio Grande Valley, these are the first students in their family to go to high school, and these are data showing how we measure the effect we're having on systems. In New York City, these are data reported by the system on the improvement in achievement in algebra of students who were never successful before. I wanted to choose special areas of R&D because this is a PowerPoint presentation. We provide real-time data at the desktop of every teacher and every student. We provide very rich assessment tools that we hope transform the notion of assessment into a learning experience. And we devote a great deal of time to developing dynamic visualizations that personalize learning, that have high functionality at low bandwidth, and that are accessible outside of class. Thanks very much.
Great job. So that was great. You can see how it's done. Next, we'll move on to Alex Corp, or perhaps you say ALEKS Corp. But all right.
Sure. My name's Lori Anderson. I'm the Director of Marketing for Alex Corporation. It's a pleasure to be here. There is so much talent in this room, and thank you for the invitation to share this meeting with you. So ALEX stands for Assessment and Learning in Knowledge Spaces, and it's an adaptive online learning program for math that uses artificial intelligence to identify and deliver personalized instruction on the exact topics that each student is most ready to learn. Now, what do I mean by most ready to learn? This is the one thing that makes ALEX truly unique compared to other programs, and that's that ALEX analyzes each student's knowledge and knows at each moment, with respect to each topic, whether each individual student has mastered that topic. And if they haven't mastered it, ALEX knows if the student is ready to learn that topic right at this moment. Now that's powerful information that ALEX can use to make learning more effective and efficient. By continuously offering students only the topics that they're actually ready to learn, we're not going to frustrate students with material they're not ready to learn, and we're not going to bore students who have already mastered those topics. And that builds tremendous learning momentum. And a ready-to-learn topic is where the student has demonstrated the prerequisite knowledge to master that new topic. And ALEX is dynamic, so as students learn new topics, ALEX updates its delineation of the student's knowledge, so it's always 100% accurate. Now, what you're looking at here is how a student's knowledge is displayed in ALEX. It's through this multicolored pie chart, which is both a student-friendly navigation tool and a really powerful motivator. Students love to fill up their pie. So if there's two things you can take away from this presentation is ALEX Pie and ready to learn. Now let me break it down for you. In this case, I've got the Algebra 1 course up here, and there's 288 topics in the course. The student has currently mastered 121 of them. Now the course is broken down into slices. The darker portion of each slice represents what the student has mastered. The lighter portion, what the student has yet to learn. When the student scrolls over a section of the pie, they're going to be given a list of topics that they're ready to learn right now. As they learn some of those topics, then other topics become available. No two students have the same pie. No two students have the same list of ready-to-learn topics. ALEX is individualized and optimized to each student precisely right now with what they're ready to learn. Now, instructors can use this powerful information to differentiate instruction and to better direct student learning. They have this really detailed knowledge of where each student is at. And this is one of our dynamic reports where the instructor can see for this topic which students have mastered it, who's not mastered it, and the subset of students who is ready to learn that topic right now. So a little information on ALEX Corporation. We are based in Irvine, California. ALEX is the result of decades of groundbreaking research in mathematical cognitive science at both NYU and UCI. We were started with National Science Foundation grants, and all of our content is created by experts with thorough knowledge and experience and passion for both education and teaching. Now, ALEX creates dramatic learning outcomes through a couple of things. We use these adaptive, artificially intelligent assessments that target and fill each student's knowledge gaps. We find kind of the holes in their learning, and we plug them up. The learning is optimized and individualized to every student, and it's always presenting to them precisely what they're ready to learn. So as a result, students are motivated, they have a deep level of understanding of course material, and most importantly, they achieve success. ALEX uses open-ended questions to maintain an accurate picture of each student's knowledge, so we don't rely on multiple choice. Here's an example of some of our answer input tools. And as a result, the inferences that ALEX draws on each student's knowledge is much more accurate than if we relied on multiple choice questions. Students undergo a cycle of assessment and learning in ALEX. So they'll start off with an initial assessment. We pinpoint their knowledge. We then introduce them to that learning mode where they encounter their pie, they fill in their they master their ready-to-learn topics, and there they encounter an open response environment, which includes personalized practice, step-by-step explanations, and tutorials and immediate feedback. The whole interface, problems, explanations can be toggled between English and Spanish, so where that's appropriate for students, they have that available. And most importantly, again, students work on what they're actually ready to learn. And we, of course, check for retention of that knowledge through periodic progress assessments. Our courses have been used by millions of students in the U.S. and abroad, from grades 3 all the way up through higher education. And as a result of all this data, we use it to improve the artificial intelligence behind our products, as well as to improve the course content that our students use. We offer a full range of courses. I've listed our Algebra product suite for middle school, and our courses are correlated to the Common Core state standards. You can learn more at our website. Thank you so much for your time.
Thanks. You guys are doing great. I couldn't be prouder. And now we're going to hear from Neil Spears of CFY, who I'm sure won't let me down.
I hope not. Thank you. Good afternoon. How are you? That was pretty good for a first try. Let's try it again. Good afternoon. How are you? Even better. My name's Neil Spears. I'm the co-director of CFY in Los Angeles. I'm here today with my colleague Granger Marburg, who's right here. Granger, say hello. Granger's our executive director here in the San Francisco Bay Area. CFY is a national nonprofit organization that for over 10 years has been helping students, teachers, and families in low-income communities use digital learning to do better in school. And we do that through a couple of ways. First, we have an on-the-ground direct service program where we partner with middle schools and low-income communities and provide students and families of those schools with digital resources, support, and training so they can use learning at home. We also provide professional development for the teachers of those schools. But I actually want to talk to you about our other main program, our in-the-cloud solution called Power My Learning, which is accessible at powermylearning.com. Power My Learning is a free K-12 online learning platform that's designed to make it extremely easy to find digital learning activities on the internet. Each of the over almost 1,000 digital learning activities on Power My Learning are tagged by subject area, grade level, and the Common Core academic standards. And as a former middle school teacher myself, I'm really excited about Power My Learning because it sort of takes that Google searching, hours and hours of Google searching for great digital learning activities out of the equation and has all the amazing materials and activities curated for me. I'm not the only one who's excited about Power My Learning. The platform has received some recent investment from the Broad Foundation, the Gates Foundation, and the Kellogg Foundation. Are you ready for a quick tour? Great. So welcome to Power My Learning. The digital learning activities themselves appear in rectangles down here in the middle of the site. I'm going to actually zoom in on some of the math activities. Each activity has a little thumbnail, a description, and the user can filter the activities by subject area using the navigation bar on the left and actually drill down into the actual domains of the Common Core for the subjects. Sort the activities by grade level. And because we want Power My Learning to be useful for parents as well as to students and teachers, and because we know that many parents prefer to use resources in Spanish, we have a little button up here, Cambiar al Español, and when I press that, voila, the platform translates into Spanish. Now let me take you on let me show you what one of the actual digital learning activities looks like. This is Lure of the Labyrinth. It's a middle grades math activity that was developed by MIT. It's got some fun features up here at the top, the ability to share, rate, and find related resources. And all of these resources are available for free to anyone with an email account. So if you're on your laptop now, please feel free to go to Power My Learning and create a free account. That said, there are some special features that we've reserved exclusively for teachers. And I want to show you one of those now because I know there are so many educators in the room. When teachers log into Power My Learning, they see an additional feature over here on the right called playlists. Playlists are collections of digital learning activities that are customized to create a special learning experience, a targeted learning experience for a group of students or for individual students. I kind of think of them as like a necklace where you can put beads on them, and each of the beads is a different digital learning activity. Then you can create this customized learning jewelry for individual students or for groups of students. Let me show you what one of these playlists actually looks like. It has the digital learning activities down here at the bottom, which the teacher can move around in whatever order he or she likes and add and subtract any of the almost 1,000 digital learning activities that are on Power My Learning. There's some student instructional text, Common Core standards that it relates to, and a teacher description. We've already seeded Power My Learning with a number of playlists. So this one about describing and evaluating algebraic expressions, it's ready to go. But teachers can also modify the playlist to suit their needs and also create some from scratch if they wish. So this is just version 2 point something of Power My Learning. We're going to continue to innovate and iterate over time. So some of the enhanced features that are coming soon include improved reporting of student usage. Right now, teachers already have visibility into how much students are using the playlist activities, and can see, and also students and teachers can see that as well. Students, teachers, and families have visibility into that. We're going to make that even better. We're going to make the search and filtering functions better, and we're going to enhance the badge and point system. Power My Learning is really designed to help educators and schools that are ready to start using blended learning models really do so with great efficacy. So I'm sure you're all as excited as this kid is right here to try out Power My Learning. And I want to invite you to come visit me and Granger in the expo at the end of the afternoon. We'd love to meet you, give you a personalized tour, and talk to you more about CFY. Thanks. Thank you very much. You didn't even have to cut me off.
No. Well, that was a close one. I was afraid we were going to make it through the whole afternoon without mention of the cloud, but here we are. Next, we'll hear from Nehru Khosla of CK12. Thank
you. If you can't see me, just stand up. So I hate podiums, but that's another story. I'm here to talk about CK12. So what is CK12? It's a nonprofit, and our mission is to provide STEM content for all K-12 students. We started with the idea that we were, kind of really upset with the fact that you had to pay so much for education. And it's absolutely not acceptable that students, especially in the K-12 category, had to deal with this. Without, with them not having any information or content available to them, it's impossible for students to teach. So that situation is completely unacceptable. You've been hearing pretty much all about the passion everyone brings and what they plan on doing. And pretty much it's the same flavor. So what we've done is created Flexbooks, which we give you the full right to use. These are under Creative Commons licensing, non-commercial, but share alike. You can actually take any one of these Flexbooks and adopt them to your own requirements or the student's requirement. These Flexbooks are for yours to use. We have many people in this audience whose districts, whose class, whose school are already using these Flexbooks. We've had over 7.5 million downloads in the last 2 years. We can't keep track of anything else. That itself shows that there's a huge need for this kind of resource. So what have we done next? We've created a knowledge tree or a learning tree which is based on requirements, which are your state standards, your common standards, international standards, or the AAA standards, or the Math Society standards, and created a superset. And this set of concepts is supposed to help support the learner. So not only in our concept do we have text material, we actually have a lot of multimodality, which means videos, which means interactive elements, which means you name it, even teachers' editions, even teachers' help, everything, lesson plans, which are all arranged either through a student view or a teacher view. So it's all for yours to do what you want to do. Just come. We don't even ask you to sign up, but it is to help you teach a student from where they are rather than trying to keep them or rather than start from where they're not. So the whole idea is come in, take the student from where they are so you can see all these different concepts broken down for algebra. Not only that, we actually provide with other people like Wolfram, we've actually provided interactive learning objects. These are available for algebra at this point in our algebra book, so that the very fundamental thing that we need to make sure our students have before they get quite turned off education, that we can help them not only just read about it, but envision all this, and to be able to solve and have practical examples that they can actually work with. This one program is our basic algebra program. It's the Flex Math, dealing with algebra. It's brought students that were 2 to 5 years behind to the present or even beyond. The results I'm not sharing here today, but LPS has done, our Leadership Public Schools has done a great job on reporting those results. There are other districts, Riverside School Districts has used them, as has some other school districts. So this is producing great results, and I'm happy to share those results with anyone who wants it. So I encourage you to come and help us make the system for you rather than making it for us. So thank you so much.
That's great, thanks. And remember, all these folks will be around after the formal program's over if you have questions. Next up is Edmodo. Jill Florent.
And we're gonna start with a video. I'm gonna give up a few moments. Okay, thank you so much for inviting us to participate. My name is Jill Florent. I'm a senior member of the Best Practices team at Edmodo. And we're going to spend the next few minutes focusing in on how to harness the most innovative social and mobile technologies in a way that is safe for students, easy for teachers, and entirely free. I wanted to start with that visual context, simply to give you a sense of what we're talking about when we say safe social networking. Our founders, Nick and Jeff, when they started Edmodo 3 years ago, really had a vision that it's always better to build knowledge in a social context, and that these new tools out there could be very, very powerful for teachers, both with their students and also with others as professional colleagues. And what we've really been able to do over this 3.5-year period is grow a worldwide network that's available to you right now to log in, create your own free teacher account. We actually have, a year ago, we had about 1 million users, and now we're at 5.2 million. I think that notion of us growing so rapidly at scale can give you confidence that this is being really used well by teachers and meeting their requirements all over the world. I think if you look at this, our actual growth numbers are in the neighborhood of like 100,000 to 200,000 new users a week. I will be inviting all of you to join my Edmodo community. In a few minutes, you might even want to get your pencil ready. I'm going to give you some important secret information. Edmodo is built upon the idea that teachers are the ones to create a productive, social learning context, and that teachers must control the safety of who's in and who's out. So we use this model where teachers create groups and share out a private secret code that's intentionally obscure. They use that to make sure that the students who they want to be there are there, and then the system only allows students to actually send messages directly to the teacher or to the whole group, and the teachers see everything that's going on. It's also a fantastic way for teachers to connect with other teachers. And if you look at this screen, this is what Edmodo looks like. A little bit of highlights here, a couple things that are most important. You can post, and it's super obvious to know where you post. Up at the top is the post bubble, and the center part is the stream. That's where all of your discussion takes place. Edmodo actually makes every one of the technology tool vendors' systems work even better because it's done in a way that is more social. Come talk to me after the session about what they're doing in exemplary ways in Singapore using our model, what they're doing to enhance engagement, where teachers are using Edmodo for enhancing what they do with the Khan Academy or getting discussions going in class, going entirely paperless, and also for professional learning communities. I have a secret code for you all to go to www.edmodo.com, and I've created a middle grades math discussion group that you're all welcome to join with the private secret code 30S1Q1. If anybody didn't have a chance to write that down, you can come see me after. And these are just some great reasons to think about using Edmodo. You can start using it today, and the most important validation of what we're doing is that if you talk to a teacher or a kid who's using this, they absolutely love it.
Thanks. These guys are on the ball. Okay. Well, Edmodo got me thinking about how great it is to be here networking and sharing all this expertise. You know, it's a lot like Facebook, except without the computers. All right. So next, we have here, any moment now, Key Curriculum Press, a team of experts. You haven't forgotten your password, have you?
I hope not.
Excellent.
Hi, I'm Elizabeth DeCarly. Can people in back hear me okay? Yes? Thanks. Okay. Ta-da, great. So we've heard a lot of talk about data today, so I thought we should probably just spend a couple minutes playing with some data. I'm going to show you Tinkerplots. It's a dynamic data exploration tool for 4th through 8th or 9th grade. And every day when I'm commuting to work, I see small students carrying huge backpacks, and it makes me wonder, how heavy are those backpacks? So one school had the same question, so they collected data from students about their backpack weights, and you can see here's one student, Angie, a 1st grader, she weighs 45 pounds, her pack weight is 4 pounds, and if we click through the data cards, we can see there's 79 students, and there's a variety of body weights and pack weights represented. We have grades 1, 3, 5, and 7 in here. Right now I just have a bunch of dots over here, but if I click on one of my attributes, like pack weight, I see that the colors change, and I'm going to expand my graph a little bit. Ooh, my menu is not showing. Let's see, how are we doing there? And if I start to separate my data a little bit, I now get bins, and I can see that I have quite a few packs in the 0 to 19 pound range and a few packs in the 20 to 39 pound range, and I can stack those up and order them if I want a little better view of the data. I'm going to continue to separate. I hear some murmuring, so I don't know what that's about. Okay, so what is going on over here? If I click on that data point, it's linked to the card, and I can see that there's a 7th grade student named Gail who has a pack that weighs 39 pounds. Totally absurd, right? But at least she's the only one that's way out there. For students, this might be a good graph to spend some time with. We can take a look at how many students are in each bin here, okay, 28 students with packs from 0 to 6 pounds. We can look at the percents. I was a high school math teacher for 9 years, so I always want to go straight on to expanding the data, but for younger students, this representation is actually quite nice. But I'm going to go ahead and drag these all the way out, and now I have a dot plot. Okay, and I can really see that poor Gail there is really probably an outlier. I can take a look at my average and see that the average pack weight in this whole data set is about 10.2 pounds. However, I did tell you at the beginning we have first grade, third grade, fifth grade, and seventh grade students. I hope the first graders aren't all carrying 10-pound packs, right? So I think what I want to do is take a look at the pack weight by grade. So I'm going to click on the grade attribute, and now I can see that I've got some other colors going on, and if I start to separate vertically, I now have separated my seventh grade students. I can see that their average pack weight is 17 pounds. I'm going to keep dragging and separating. Okay, this makes me feel a little better. The first graders are all clustered down here at the low end. They have an average pack weight of about 5 pounds. So, and it's interesting to see this spread in the seventh grader. I'm not sure how this Chad is getting away with only having a 3-pound bag. I don't think he's taking his books home. Okay. I have no idea where I am in the time, I'm sorry, because I've gotten into playing with my data. Okay, so I really want to echo what Phil Darrow said. I think we need to spend more time on middle grades mathematics, more time tinkering, more time exploring. And I don't want to see math as a bunch of separated little bits, atomized objectives, but rather as a connected whole. And I think when we use technology to explore mathematical ideas, where students are creating mathematics with the technology, we can go a little deeper and let them take the mathematics a little deeper. If I have time, I'm going to show you one other little thing that tinker plots can do. I've set up a simulation here for rolling 2 dice, and I've graphed the sum of 2 dice, and you can clearly see from my graph of 50 dice rolls that when I roll 2 dice, 10 is the most common result. You can clearly see that from my 50 rolls, right? It's the highest. I'm going through this graph very quickly. Let me try another experiment. I'm going to try rolling my dice another 50 times. Oh, shoot. This time my most common roll was 6. 8. Okay, what I'm going to do, instead of repeating 50 over and over again, is I'm going to just run a quick 500. If I wanted to, I could try 1,000 and so on and so forth. So come see us at 3 o'clock, please. Thanks.
Thanks. So if you're live tweeting this event, I'm using hashtag God, I'm glad I don't have to take algebra again. But maybe this is the wrong crowd for that. Okay. Is it set? Yeah. Okay. So I'm trying to be impartial and supportive, but I got to say it's now time for my favorite named organization.
Oh yeah, and the second half of key curriculum press showing the geometry sketchpad.
Oh, no, it's not. Bummer.
Should I just go?
It's the second half.
So I'm showing you the geometry sketchpad, which is another. How many of you have heard of the geometry sketchpad? How many of you think it's just for geometry? Well, most people do, and so my 2 points I want to make today are, one, that sketchpad's also a dynamic algebra environment, and that sketchpad is a powerful authoring tool. You can explore in it, but you can also create models to explore pretty much any level of mathematics. So first point first, algebra, dynamically. What does dynamic algebra mean? And how do I get my, there we go. So the first thing I'm going to do is define a coordinate system. Now, I could just graph a function, which is what you do on a graphing calculator. I could plot a new function, and I could plot 2x minus 5, and it would plot the function just like a graphing calculator. But one of the Common Core standards is that students should understand that a function has inputs that result in a single output, and that there's a relationship that may form a curve or a line. And so you get a much more powerful understanding at the middle school level in particular of what a function plot is if you do this little sort of activity first. I'm going to put a point on the x-axis and measure its x-coordinate. And I'm going to change this to label. I'm going to call it N. And then I'm going to just do a calculation, straight up calculation, no graphing yet. I'm going to calculate, let's say 2 times this number, minus 5. And right now it's just a calculation. So the interesting thing at this point is, and I'm going to go ahead and change the name of this as well. You can see it's 2 times n minus 5, but for right now I'm just going to go ahead and call this out. And if I go back and drag my original point, you will see that the values change. So as the in value changes, the out value changes as well. So what I can do next is select these 2 points and plot them as an ordered pair. And so I get this new point now that when I drag around A, you see that this point is sort of following a little path. Now this is what I mean by dynamic visualization. You can see a relationship here only through the movement. Well, we could, whoa, I might need help because that's not what I wanted to do. How do I, oh, there we go. Help, I don't like your settings, Elizabeth. Okay, so what if I wanted to see where all these places it might go? Well, one thing I can do is trace it. So as I start tracing this point, you start to see that it leaves behind a path, and you're really starting to get down to the fundamental idea of what a function plot is, right? Because now we're looking at a trace of all those different locations of the out depending on where the in number is. And I think that buildup is why I think dynamic algebra is a powerful part of Sketchpad. But you can create models as well, very elaborate models. I'm just going to show you a few that are sort of relevant to the middle school level. So, you know, here is 7 minus 10, and if I want, this is an animation that shows subtraction. This animation is dynamic in that it can be any numbers. So I could take different numbers of starting. I can see what happens when the first number is bigger than the second one, so forth. Okay? Mellow yellow, this is a big idea, is graph interpretation. What does this mean? Here, you can discuss it first with your class, then you can press go. And you see simultaneously an animation of the situation as well as an animation of the graph. And you discuss what is the story telling. You know, eventually you will be able to show the story. Now the details here aren't so specific. You know, you can make up your own color. But you know, there's some things you can figure out from the graph. And then you can go to other situations where here's the story first, and here's this graph. Is this graph correct? Is it not? If it's not, fix the graph or change the story. You got different choices, but this is a graph where you can drag different things. You can try to drag the end point to left of this point and it falls apart. Why? Okay? Good discussion topics. You know, it'll just happen. Okay? And eventually, once you think you get it right, you can test it by actually running the simulation. Well, here they're supposed to be going backwards, and that wasn't part of the story. Okay? Simulation, here's a typical sort of rate, time, distance problem. Wouldn't it be nice to actually do a simulation of this before? Sorry, not my computer. And so what's even cooler here, though, is you can actually show a time slider. Since when, you know, this idea of can you dragging time around? Well, that's not something you can do in real life, but you can still model it. Okay? And then you can model, this goes back to the first sort of idea, right? You finally get it all plotted, you get these points here, you can trace those points, okay? And then you build up this idea of a function plot and a solution to a system of equations. You can model equations through this, and you know, these are just models that I'm quickly running through, and I'll be happy to show you more if you come by and talk to us this afternoon. But here is the equation, step 1. The 0 gets removed. And all of these things are built in the native capabilities of Sketchpad. Thank you.
So you've just witnessed a classic case of brains over brawn. I can be as tough as I want, but they figured out 2 times 5 equals 10. So, but now, Mathlicious. And as soon as we get the computer set up, we'll hear from Kareem Kai Ani. I got that right? 2 times 5 is 10? Right. Got it.
So while these guys are breaking this stuff down, I will just say that Sketchpad really is like the coolest thing I've ever seen. As someone who spent way too many Friday nights doing Sketchpad, that's probably why I'm still single. Am I going to need this? Ladies. All right. So, how are y'all doing? So, Mathlicious, my name is Kareem Ani. I'm the founder of Mathlicious, and that wasn't supposed to happen. Y'all cool back there? So, in the U.S., I think y'all are on the last slide, because the last and the first slides look the same. Let's try this. All right. So, in the United States, according to a Raytheon study, 61% of middle school students say they would rather take out the garbage than do their math homework. And when you ask them why, the responses tend to be, I don't know what math means, and I don't know when I'm ever going to use it. And it makes sense. If we look at the way math is traditionally taught, it's typically taught as a bunch of random skills for students to memorize and regurgitate on a test, right? And it's boring to students, it's dry, and it's totally irrelevant. And even when we try to make it relevant, right? And so this is bad, not only is this bad for students, but it's also bad for teachers. Good content sets teachers up, bad content sets teachers up to fail. And so that's what we're trying to fix at Mathlicious. So we write classroom lessons for classroom teachers, but around real-world topics that students care about. So for instance, have video game consoles followed Moore's law? Exponential growth. Is it ever a good idea to buy a 6-inch pizza? It's 56% crust. Buy breadsticks, right? Or how about this one? So in the lesson, this is what the lesson page looks like. In the lesson Wheel of Fortune, students begin by analyzing the wheel and determining what percent of the time each piece should come up. So for instance, bankrupt on the real wheel should come up around 12% of the time. But when they watch the episode, students find that bankrupt actually comes up about 15% of the time. From the student's perspective, this lesson is about this. But from the teacher's perspective, it's about this. Ratios and proportions. Displaying numerical data. Now you'll notice how many Common Core standards are addressed in a simple lesson about is Wheel of Fortune rigged? So when we use Mathlicious lessons, teachers are able to get through more material in less time in a way that makes sense to students. Let's look at another one. Let's look at a lesson called Bigfoot Conspiracy. So have you ever wondered whether people with small feet pay too much for shoes? For the same price, they're getting less shoe. And so, using ratios and proportions, what would happen if Nike charged by weight? And should they? Let's look at another one. One called I-Cost. Oh, I think we're on the wrong. Oh, well, I guess we're looking at a different one. So, I guess that's the wrong slideshow. So, teachers have to teach exponential growth. Now, we can ask, as you go back in time by generation, how many people are you related to? Right? 2 to the x, pretty simple. And so we can ask students, what if you go back 100 years? We can ask students, looking at the population of the Earth over time, how far would you have to go to be related to everybody on the planet? That's cool, right? Now check this. Because if we can all trace our ancestry back to the same people, and if you can say that, if I can say that, if you can say that, then aren't we all related? So we start, as a lesson on exponential growth, but it ends up being a really interesting conversation. Do taller sprinters in the Olympics have an unfair advantage? Should Usain Bolt have to run farther than everybody else? Speaking of exercise, what's the best heart rate to burn fat? We can do health and wellness. But maybe you actually don't even need to do exercise. Maybe fast enough music will cause your heart rate to go up by itself. Right? Linear functions. But speaking of music, how long would it take to climb a stairway to heaven? And since you're up there, find out, are we alone? What are the odds of finding life on other planets? So imagine, using lessons like these, will students ever ask this? Will they ever ask this? Will students ever say this? And we know the answer. In a recent survey, 95% of teachers said their students enjoy the lessons. 97% said they help them make them better problem solvers. 71% of teachers said they enjoy their jobs more when they use the lessons, and over half said it's changed their approach to teaching. That's kind of a big deal. This was the biggest gripe. They want to see more. Now, just to conclude, we're talking a lot about technology, and technology is great. Apple just announced this new textbook tool. And this technology provides us a wonderful way to engage students, right? It's a great tool, except will this address the student question of what does this mean and when will I use it? Technology is a great way to distribute content, but we need good content to distribute. And that's what we're trying to do at Mathlicious. We're trying to put teachers in a position to engage their students, teach meaningfully, and actually have a good time doing it.
Great. Very, very entertaining. It is all about the content. Next up is the Monterey Institute for Technology. Ruth? Oh, we've met.
Hi. All right, I've got a lot of slides that I want to speed through to let you know about the project in general and sort of set the context for the project that is an Algebra 1 project, in particular due to this audience. So let's go. Oops. All right, so Algebra 1, we've called this project an open course, New Resources for New Approaches. We're a nonprofit organization that is the home of the National Repository of Online Courses. We're known as NRock, so many of you may have heard of that acronym. NRock is a whole library of content, and you can really find out all about the current math project at this URL, nrockmath.org, because there's a lot to say. This originally was a project funded by the William Flora Hewlett Foundation as part of their open education resources portfolio. And the idea behind it was, this was in the early 2000s, to try and develop a resource where we could gather a lot of rich digital media in education that's been created, that's of high quality, it's curricular, media rich, flexible, and has a sustainable model so that after grants go away, there is the resources that are there and they continue. And we've developed a network model of institutions to help support it. So there's a number of programs that we have. The library itself is a digital library of these high-quality media resources, and they're mainly for middle, secondary school, and the first couple of years of high school. A lot of the resources in the National Repository of Online Courses were originally funded by public funds in California through the University of California, some projects there, and we have repurposed them. We have an agreement with UC to repurpose them for this use. Once we had this library and started working with schools around the country, we realized that we wanted to have a membership network where people were part of a learning network and sharing resources and ideas. And we also wanted to make all of these resources free to anyone, anywhere. And so hippocampus.org, if you don't remember anything else of what I say, check out hippocampus.org. This is very similar to some of the resources that my colleagues have talked about, where there's free digital media resources around a lot of subject areas. Teachers and students can use it. There's playlist functionality, there's customization for your classroom. So please explore this. And the Algebra 1, an open course, is on this site, and it is available. There's no testing on this site, but all the resources are available, and there's self-testing for students. We use a very collaborative approach that's research-focused, and importantly, the point I want to make here is that we work with our member network around the country. We've done focus groups and professional development workshops with people that are administrators, teachers, and students. Right now, this algebra course had focus groups with people in a lot of different schools. We talked to students and showed them the product as we went along. A lot of what we heard was the existing products are they're too expensive, and so we came up with too expensive, not flexible enough. So this project, you can see a use case about it. Multimodal, it's evidence-based, it can be used in any learning management system, and there's both self-assessment, there's a whole range of activities. These are conceptual presentations followed by Saul Kahn did these for this project, some worked examples. There is practice problems, and the student gets feedback, and it's adapted to the student's feedback. There's an integrated textbook that can be printed, and there's manipulatives to do simulations and to understand. There's then a review section where there's different items that a student can use to make sure they're prepared. We have project-based learning activities that can be used for groups, tutor simulation, and games. And you can find all of this at, I'm going to the last slide, focus groups, research sites. We currently have research sites going all around the country.
Thank you.
Come talk to me.
So yeah, people will be around after the program, remember, and now we move on to motion math with Gabriel Adauto. You probably have more use for this than I do.
Okay, thank you, Mike. Hi, so I'm Gabriel Adauto, and we're in the middle of our slide deck. Awesome.
And I'm Jacob Klein. We're the co-founders of Motion Math. We make games for mobile that help kids play with numbers. These are apps currently available on iPhone, iPod Touch, and iPad. We'll soon go to Android as well, that help build that fundamental number sense that's so crucial for elementary and for middle school students. Increasingly now, with the proliferation of mobile devices in schools, parents, teachers, and kids are asking, is this a good learning app? What makes an effective app on these devices? And we think there's many components of a successful learning app. Is it intuitive enough to just begin quickly, and yet challenging that it takes a long time to complete? Does it build an actual conceptual understanding of the subject area, not just a thin procedure? Is there an efficacy study to demonstrate a learning effect? We put one of our apps to the test, got a really great result from an efficacy study, and we're hoping more people, more companies in this space add that rigor. Is it fun? These are devices that really captivate children's attention, and so the app should build on that and get kids engaged. And lastly, is there feedback? Is there positive feedback to let a child know that they're learning, that they're progressing? Is there a way to chart long-term progress? But then also, and this is the component, the one component of our design that we want to focus on today, what about negative feedback or scaffolding? What about when a learner doesn't know what to do? Well, if you're
looking at a textbook or flashcard problem and you don't know what to do and just stare at it, nothing happens. You can go to the end of the textbook or flip the flashcard over and find out the right answer, but it's very binary. You're either right or wrong. And it's most productive when students spend a lot of time actually between those two, not being totally confident on the answer, but having some sense of where to go in a problem, needing some help, maybe some hints to get the right answer. So we build these kind of hints and scaffolding into our games. One example comes from our fractions game on iPad. It's called Motion Math HD, in which you have to estimate where a fraction goes on the number line. And fractions in the game are shown in multiple ways, as numerator over denominator, as percent, as shown here in this slide, as a decimal, as a pie chart. And if a student is struggling and not able to estimate where that fraction goes, we give increasingly helpful hints. At first, it's a directional arrow. Then they're a little thin in this to see in this slide, but there's hash marks, which reinforce the concept of denominator. Then there are similar fractions, again with that same denominator and different numerators. And then eventually, in early levels, there's an arrow just helping the student along to say, right here.
In another game, Motion Math Hungry Fish, we have kids combine numbers to a goal number that's represented on the fish. You can see in this case it's -11. One area of scaffolding is going to be the mean fish. He's going to tell you when the answer's wrong because he's going to eat it. And eating things in our games makes things bigger. Once the mean fish gets big enough, guess who it eats? Your fish. So, what happens when a kid just sits here and stares at it? Now, to be clear, so in this case, the goal of the fish is 10, and 9 and 1 is the right answer. You can imagine there's lots of different goals. In this case, 8 and 2 is the proper answer. But if a kid's just sitting there and staring at it, they end up, the wrong answers fade away, and the kid is left with the right answer to make that and have that moment of getting the answer right. In another game, Motion Math Zoom, we have kids take numbers and pop them on the right place on the number line, connecting different animals to different place values or magnitudes on the number line. Here, much more complicated number, 0.006, and kids get lost. The number line is an infinite space, and so you can just get lost. What scale should I be at? After 40 seconds, which is incredibly long in video game time, we pop up a want help. Now, a lot of kids, and this is an amazing thing, they don't want the help. They just keep going. And the cool thing is that they will persist through this to get to the end of the number line, where we'll take them back to where they got lost in the first place. We'd love to have you all come over and try these out and experience the kind of engagement and delight that we create.
Great.
Thank you.
Thanks. Thank you.
So it turns out it's a fish-eat-fish world. But next we'll hear from Edith Harrell-Caperton with Worldwide Workshop.
Hi, everyone. Thank you, Mike. So good to be here. I had a presentation. I changed it since I'm the last speaker, and I thought that we're going to all go and look at the technology later. So I'm thinking all day long, since 8 o'clock in the morning, how algebra is this body of knowledge that is so hard to master. Do you agree with me? Raise your hand. Is algebra hard to learn? Is algebra hard to master? You don't agree with me. You do agree with me. Great. So we're all thinking really hard about it and how to make algebra be more connected to our hearts and our brains. Let's not forget that that really is the key. How to make this huge body of knowledge that has some bodies of knowledge connected to it that you kind of learned before algebra and as you're messing around with algebra, how to make it let's kind of all do this, like really touching our hearts and our brains. And I think that's key because we want to make algebra sticky, because we believe, we saw all these statistics, it's going to help us when we grow up. And so how can technology help to that? And Mike, maybe some of you heard me say this before. I personally believe that coding, software engineering, game design actually are the new manufacturing. And they are in themselves very important skills, new literacies, for students to learn. And clearly, for that, algebra is such an important thing in order to master coding, computer science, and simulation, demonstrations, and game design. But coding is also important to algebra. And this is the story that I would like to focus about today. There is an interesting symbiosis, very interesting relationship of the contribution and the relationship between algebra to coding and coding to algebra. And so how are we going to change master schedules and how are we going to really make it happen? That's a problem I've been dealing with for almost 30 years. I'm that old person in new media. And back in the Media Lab in the 80s with Seymour Papert, anybody here remember Seymour Papert? No, Seymour Papert. He is my professor of mathematics. He is the mathematician that made me fall in love with mathematics and understand algebra. All the point that I actually decided to connect with coding and algebra and rational number concepts, pre-algebra concepts, in my thesis at MIT, my PhD at MIT Media Lab. And I discovered already then, 85, 86, 87, 88, that when kids program a piece of software or a piece of game to teach other kids about fractions, they actually learn a great deal, like computer scientists, like cognitive scientists, like teachers. They learn by making, they learn by teaching, they learn by explaining. And so since then, I've been this passionate constructionist that is trying to make constructionist learning relevant for the new generation. So all these amazing tools and amazing apps, I want kids to make them. These guys are having all the fun, right? They're thinking so hard about what's hard to understand. How am I representing it to other? What are the levels? What kind of concepts am I going to put into this fractions app? I want our students to be the app creators because I believe that that's the process of epistemology Seymour Papert taught me about. In his learning ontology, he has these 5 key terms that I would like to remind us. One is mathetics. It's a Greek word, which is the opposite of pedagogies. It's the art of learning and how learning happens best. The other one is dirty dancing, very much inspired by the movie. And it's the art of passionate, fluent learning. Just like when you learn how to dance or other things, some mathematicians actually talk about that flow. Epistemological perestroika is a term that Seymour brought from Russian perestroika to really prove that change is possible and it can happen very fast. And Robin Hood vision was the term to stealing best learning that is happening in those companies and bringing them into schools. So let's put that video number 1, to end my presentation for today. And come and see us in that desk outside. We'll talk about Globaloria. No, we have to put this video on. One second. Technical problems. So this is a video of teachers and students who are part of this large network. Yesterday in the Digital Learning Day, we opened 60 schools. Is video number 1 going to play? Yeah. 60 schools opened their doors to show Globaloria to their communities all throughout the nation.
My name is Melanie Shepard. I'm a teacher at Eastern Greenbrier Middle School. I teach pre-Algebra 7 and pre-Algebra 7 Advanced. My students are working on games that involve 7th grade math CSOs and also social issues. Social issues that are being covered are saving pets off the streets, breast cancer awareness, water conservation. The students did research on social issues, discovering several websites that had the information on the social issue of their choice. Then they chose a math concept, and they put the math concept in with the social issue. By choosing their own topic, students have to work the problems out in order to find the answers. They also have to figure out which answers a player may choose that is similar to that, having them go along and fix the answers to where it may be a mistake that the user may actually make. By forming their own problems, having to find the answers, I do believe that the students can make that information their own, and by making it their own, they have a better retention. Global Laureate has actually revived my teaching because I can actually put myself easier into the shoes of the learner. I know exactly how the students feel when they cannot do something or they've never seen something. So it kind of gives me a view on I need to be a little bit more sensitive to that.
Thank you so much. We have 55 documenters like this on globallaureate.org from teachers, students, middle school and high school who are learning pre-algebra and algebra through game design. You're invited to talk with us about that. Thanks.
Well, thanks very much. Well, that was certainly inspiring, and it looks like there's a lot going on, and you can see more about it at the end of the program, I think at 3 o'clock.